So I'm really looking at day 3 homework because y'all went back and did when the degree was 1 bigger on the top. So you went back to number 20 and found with long division the asymptote should have been y equals x minus 3. And then we'd skip 21. Why did we skip 21? Because the top is bigger by 2. The rule is that it has to be bigger by 1 if we're going to find it. And then let's see, same. 27 is bigger by 1, so you do long division, and we should have 3x plus 6. 28 is bigger by 1, but when you do the long division for this one, you have to add zeros, so it makes sense. But your remainder you don't have to worry about. We talked about that because it goes to 0. So 28, you need a 1, y equals x. You can call it a slant asymptote or oblique, either one. 29 is not. 30 has 1 bigger, so we need to do long division. And 30, we should have gotten x plus 1, y equals x plus 1. 31, no. 32 is bigger by 2, so we don't worry about it. 33 is bigger by 1, so y equals x minus 11. And then you don't worry about the remainder. You don't care about that at all. So we've got, and these rules are written down at the bottom of this. I called it recap. We can start our lesson there today and see about putting it all together because we want to try to sketch it out. So let's go to notes for this and see if we can practice some stuff. It's really large. That we've got a test Thursday. So I told you could have a note card. And I would think the note card would want to have vertical asymptote, is where the denominator equals 0 and doesn't cancel. What do we call it if it cancels? Because that's a whole. So the denominator equals 0, and we write those as x equals something. Like if we had x plus 2 over x plus 3, our vertical asymptote would be x equals negative 3. Okay? Vertical asymptote. You also want to have horizontal asymptote. So this talks about end behavior. So we're looking at end behavior. When x gets to be really big like infinity or negative infinity. That's not really one word. It's just written close together. Horizontal asymptotes, there's 2 flavors of horizontal asymptotes. One of them are where the degrees are the same. And then it's going to be y equals the ratio of the numerator to the denominator's coefficient. Okay, so the degree is the same, and you take them in the front. So if you had y equals x squared plus 2 over 3x squared plus x, our actual degree here, because it's the same, since the degrees are the same, the asymptote would be y equals 1/3. It's the numerator number and the denominator number. Degree is the same. Number 2 is when the degree on the bottom is greater than the top. It doesn't matter what it is on the bottom or the top, it just is bigger on the bottom, and that's going to be y equals 0. So that looks like y equals 2x cubed plus 77 over 2x to the 4th. You don't care about the 77 being a really big number, you only care that the denominator is bigger on the bottom. And the third choice was, what if the bottom's not bigger than the top? So this is called a slant asymptote or oblique, but slant shorter. So a slant asymptote is when the degree on the bottom is less than the top by 1. And that would be long division. Okay, so note card should have all of that stuff. What else can you have? I will also allow you to have that that graph page that has all the parent functions, because you might have translations and stuff. That was in this section. So what else could you have is that graph cheat sheet. And it's posted in Google Classroom somewhere. It's the one that looks like this. You could reprint it, or after class you could ask me to go and find it. Bless you, and graph it again. Because we said these are the functions we know up to a point. Like, we don't know exponential yet, so I wouldn't ask you about exponential. But I might ask you about a cube or a cubic. I might ask you about 1 over x or 1 over x squared, and you might have to translate them, okay? So you can use this too, just so you don't have to panic about some of the big things, and you can tell me about all the rules that happen. You still have to be able to factor on your own and stuff like that. So that's Thursday. Just so everybody's on the same page with what you can have or not have. Let's look at what it would look like to graph today. So we're going to put it all together. We're looking at, this is still section 4.5. It's the last section in this book. And this chapter is about, it's not the last section in the book, it's the last section in this chapter. This chapter is about polynomial functions, and what we're doing now are polynomials in a fraction form. So let's say that we were going to take what we knew as far as functions and graph something really interesting. So let's see what we could graph. Let's graph f of x equals x squared minus x over x minus 1. To do this, we're going to note, number one, that it is a rational function. So it's going to have asymptotes. It probably has vertical and horizontal ones. And we're going to go through our note card, and we're going to go step by step and list each one. We're going to start with number one, the vertical asymptotes. Does this have any vertical asymptotes? We don't know yet. We need to factor it first. How do you factor the top? No, it doesn't have a 1 here. They both have an x in there, so let's take it out. So greatest common factor? Okay, x. And then x minus 1. So what about that? Is x equals 1 a vertical asymptote or a whole? So these would cancel, and so we know that x equals 1 is a hole in the graph. So what does that mean? Well, that means that this original function is going to look like x. But at x equals 1, there's going to be a hole in the graph. So we know how to graph x plus 1. We know that we can make an xy chart. We could think about rules. So, I'm sorry, just y equals x. We know that one is just, if it's 1, it's 1. 1 goes to 1. 2 goes to 2. They're the same. But at x equals 1, I need to erase it and say there's a hole there. And you don't have to erase it necessarily. You could just put a fat hole there, and I'll understand you mean hole. But it looks just like x because these canceled, but this graph has a hole there. Which we never had that before in our lines, and now we do. Let's graph the same kind of function, but let's change the denominator. So let's say g of x is going to be x squared minus x. But let's make it x plus 1 on the bottom. And now we're going to go through our whole long list of stuff. We want to start with the vertical asymptote because this time nothing cancels. I don't have any holes. So always start with the denominator. This is going to be x plus 1 equals 0, x equals -1. And if you solve it like that, you get the entire equation, including the x equals part. This is the vertical asymptote. So I'm going to go ahead and draw that in. Crosses x at -1. I'm going to draw it as a dotted line. That's the vertical asymptote. Take a look at the stuff that I put in your notes for horizontal asymptotes. Next, we need to compare the degrees. What do we have for the degrees? Are they the same? Top and bottom? It'll be a division problem. So they're not the same. It's not a horizontal asymptote. This one grows faster because it's got a bigger exponent. So we need to actually divide it out and say x plus 1 goes into x squared minus x. And what we're going to get out is a y equals mx plus b sort of form. So it'll be a slant asymptote. And let's see what that is. X goes into x squared how many times? Okay, so let me say it again. X times what is x squared? X. X times x is x squared. X times 1 is just x. Draw the line. You have to change the signs so that cancels. Negative x plus negative x is negative 2x. What does x multiply by to get negative 2x? Negative 2. So when we multiply this back out, we're going to have negative 2x minus 2. Change the signs. We get 3, but we don't care about the remainder. Because if we write it as 3 over x plus 1, this ends up going to 0, like our asymptote rules. So we don't care about that. We say this is the slant asymptote, y equals, and we have a line. We go back to graphing the line. And that has a y-intercept of -2, so -2, and a slope of 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to connect that with a dotted line as well. If you're not sure, make an XY chart, okay? Plug in some values and see what you get out. So here's what's going to happen. I'm going to have shapes that follow these dotted lines. This is what's so cool is that we get to draw in the stuff just from this. And there's one other piece of information we can get. If we set the top equal to 0, we're actually going to find out where it crosses the x-axis. So those are called the X-Intercepts when we set it equal to 0 and solve it. So if we do this, x times x minus 1 equals 0, and separate it out, x equals 0 and x equals 1, those 2 points are where it crosses the x-axis. Now what does that mean? Well, that means that my function is going to follow this line down, and then it's got to like come down so that it can go hit this other x, and then it's going to follow this line out. This is the actual function graph. Because it follows the dotted line. Now, the rest of my function, and I probably should have moved this up on my paper because I can't see everything. I need to know whether I'm going to be graphing up here so it follows the line like this, or whether it's going to be like a down V down here. How do you think we could figure that out? Do what? So plug in a point. So we could do that. We can say, well, what happens at -2? We could actually plug it in right here and say -2 squared minus -2 over -2 plus 1. What does that give us? Can you see it all? -2 squared is 4. 4 plus 2, right? That's 6. How about -2 plus 1? This is -6. So at -2, I'm at -1, 2, 3, 4, 5. I'm down here. So it's going to go like this. This is going to take some playing for us to see what happens. But guess what? I cannot have, I'm going to draw this in just so you can see it. But I can't have this and this, because then it wouldn't pass the vertical line test, right? It can only be up here or down here. It can't be both because it wouldn't pass the vertical line test. Also, I only found these two values when I set it equal to 0. It doesn't cross the x-axis here, so it's only got to be down here. Let's do some more. Let's say that we have this equation. This is example 3. And I'm going to go ahead and factor this for you. I'm going to write it down factored so we can just concentrate on all the things we can pick out. So this is h of x. It says x squared plus 1 on the top and x plus 5, x minus 3 on the bottom. So number 1 that we need to find are the vertical asymptotes. 1 is for vertical asymptotes. Where will they be? Is that where the numerator, we compare the top and the bottom, or whether we do the denominator equals 0? So that happens at x equals -5 and x equals 3. This one has 2 vertical asymptotes. Is everybody good there? Okay, vertical. Number 2, we're going to compare the degrees. So number 2 is about horizontal. So if you multiply the bottom out, what would the degree be on the bottom? It would say x squared plus 2x minus 15. Okay, that's what it would say. Compare the degrees for me. Are they the same or different? They're the same. What do you do when they're the same? It's going to be y equals, if it's horizontal, they're growing at the same rate, right? It would be 1, because we compare how fast the top grows. It grows at a 1, and the bottom grows at a 1. So this is 1 over 1, or 1. Okay. All right, so we have x equals, we have y equals. There cannot be a slant and a horizontal, so we can skip slant. Skip slant. Now we need to find the x-intercepts. So number 3, that's number 4. Let's find the x-intercepts. Does the numerator ever equal 0? X squared plus 1 equals 0. Is that ever possible? This is a positive number plus a positive number. It won't. Also, if you tried to solve it, you'd have x squared equals -1, and that's not something we'll be able to graph. So there are no x-intercepts. It will not cross the x-axis. So what do we have? Right now, we only have a vertical line at -5. 1, 2, 3, 4, 5. And a vertical line at 3. I probably should have given myself some more room, and I did not. There you go. This one is horizontal at y equals 1, so it crosses y at 1. And these asymptotes have split my graph into 6 sections. 1, 2, 3, 4, 5, 6. And I can only fill 3 of them, because I can't fill ones that are on top of each other, or else it won't pass the vertical line test. So number 1, keep that in mind. Okay. Also, it doesn't cross the x-axis. So I don't have any time where it's going to cross the x-axis. So it's probably going to be a little bit in the top. We'll have to figure that out. I can figure out one more thing. I can figure out the Y-intercept. I can plug in 0 for x. And so what would I get there if I plugged in 0? I have 0 in the top. 0 plus 1 is 1 over 0 plus 5 is 5 times 0 minus 3. That's going to be negative 1/15. And the reason I want that is because it tells me where I'm going to hit on the y-axis. And if this is 1, this is negative 1/15. It's really close to the x-axis, but not quite. There we go. Sorry. If we plug in 0, we get 1. If we plug in 0 in the bottom, we get negative 15. So negative 1/15 was our y-intercept. So this is what our graph looks like. This is a complete sketch, okay? Not perfect. But it's going to go follow this line until it hits this point, and then it's going to come back and follow this line. It cannot cross this dotted line because it's vertical. You cannot cross a vertical line, not allowed. If I have it in this bottom, can I have it in this section in the middle? Could I have a graph up here like this? No, but would it pass the vertical line test then? Okay, so you can only do top or bottom. You can't do both. So we've done the bottom here. Now we have to look on this side and this side and take a guess. If I don't cross the x-axis, because see there were no x-intercepts, no x-intercepts. Do you think it's more likely that I'm going to be up here where there is no x-axis or down here where there is an x-axis? Yeah. So that's the key, is that there wasn't an x-intercept. But if you're not sure, all you have to do is say, well, what if I try 4? What would I get? So 1, 2, 3, 4 is on the other side. You could actually plug it in. You could test x equals 4, and you would get, let's see, 16 plus 1, because I plug in 4 there, 16 plus 1. And then if I plug in 4, I get 9 times 1. That's 16 over 9. That's bigger than 1, right? Because 9 over 9 would be 1, and this is 1. So I know it has to be on this side. And then the same thing over here, we would get a positive value. Do you get the point where it can't be in both vertical places? Okay. So if you had put it here and you drew a vertical line, it wouldn't be a function anymore. And these are functions. So kind of what we're doing is we're drawing boundaries, and then we're picking the place it can go. And we're doing that by just testing some stuff. Let's try another. Let's see what we got. All right, so example 4 says x plus 5 over x squared minus 1. I'm going to do the same things in the same order. I'm going to, number 1, find the vertical ones. Number 2, I'm going to check for horizontal. Number 3, I'm going to check for slant. Number 4, I'm going to check for X-Intercepts. And number 5, I'm going to check for Y-Intercepts. I'm going to do those 5 things. And then I should have kind of an idea of what my thing looks like. Vertical, horizontal, slant. And it's either going to be one or the other of these. It can't be both. X-Intercept and Y-Intercept. Right now, we need to factor it out. So what should the denominator look like factored? What's that special rule? This is the one you were doing earlier, Diggs. Okay. So factored form, you can see the asymptotes more clearly. In this form, you can compare the degree more clearly. Kaylin, what do you think the vertical asymptote or totes are? Okay, and we want to write it out as an equation. So x equals -1 and x equals 1. Write out the entire thing so we know which axis it crosses. Isabel, do we have any horizontal asymptotes? Which one is bigger on the degree? The bottom or the top? Okay, the bottom. So what does that mean our asymptote is? It's going to be 0. So this one's bigger on the bottom. The bottom grows bigger. So if the bottom grows bigger, it's going to be y equals 0, and that means there's not a slant. Okay? Bigger on the bottom.
But if it's bigger on top, it would have a slant.
Bigger on the top means we're going to do long division. So what happens is this ends up being like 1 over a million. Well, that's really close to 0. Okay, when you think of it like that, how fast it grows to infinity,
Yeah.
It makes more sense. All right, so if we have one here, we don't have one here. How about X-intercepts? That's where we take the top, x plus 5, and set it equal to 0. Do we have any of those? That's 0 for y. What's the x value? -5, good. How about the y-intercepts? If we plug in 0 for x, so see how these are like opposite? So if we plug in 0 for x, we get 5 over -1, so -5. Okay, I'm going to leave all that up there. I want you to draw an XY axis, and I want you to see if you can plot those different things and see what that tells you so that you're thinking on your own a little bit, and then we'll come back and do it together. All right, so this is a lot of stuff. That's why I'm sort of making a list over here, and I want to think about it the same way every time so that I have an order to what I'm thinking about. These are verticals, so I've got -1, +1, kind of skinny. Y equals 0, that's here. I have -5, 0. 1, 2, 3, 4, 5. It actually crosses there. That's surprising. But that's okay. And then I have 0, -5, 1, 2, 3, 4, 5. So because this is on the asymptote, which is okay because I'm allowed to cross a horizontal asymptote here, let's check some points around just to see what happens around -5. Yep. So these are points.
Oh, okay.
That's just the intercept where it crosses. So the first were asymptotes. They're borders, but these last were points. They're trying to help me decide where the graph goes. So I'm going to test some points around -5, like -6 and -4. If I plug in -6, I get Negative 6 plus 5 is negative 1. And negative 6 squared is 36 minus 1. I'm sorry, 36 minus 1 is 35. So at negative 6, I'm going to have 1, 2, 3, 4, 5. Negative 1/35. And then at negative 4, I have negative 4 plus 5 is 1. 4 is 16 minus 1 is 15. So I have a positive number. So now I'm still confused. Maybe I need to check something like negative 2 and see what happens. So negative 2 would be 3 over 4 minus 1. 3 is 1. So that's 1. This was 1/15. This was negative 1/35. So at negative 2, I'm at 1. So what this does is kind of crazy. It goes like this, and then it's going to follow the line from there. They do that sometimes. I'm not going to give you tricky ones when I test you. This one is going to follow the line. Or does it? Yeah, it has to go this way. How do I know that? Can it come up from here? Can it cross right here? Does it have any other X-intercepts? It doesn't cross the X-axis, so it can't be. It has to go down. And then what happens on the other side? I don't know, so I'm going to test a point like 2. That would be a positive number, so it probably looks like this. The ones that you have are pretty straightforward as far as having a graph. I just made that one up. Okay, so you have some practice tonight with this kind of graph. I seem to have lost my... So we're looking right here. That's the wrong class. Sorry, I can't click things. We're looking right here, and I have the solutions already here because this is hard and I want you to see how much I've written out so you can check stuff. I've got the zeros, I've got the Y-intercept, I have it in a different order because apparently I did it in a different order last year, and I've got the vertical and horizontal asymptotes. And I might have done an XY chart. So I have plenty here for you to look at when you're doing all of it. So I want you to try the solutions, and then they have some where they've already got some things graphed, and you have to match them up. So it says, looking at this, you can't see it, it says, for each graph below, find the vertical asymptote. So they give you an equation and a graph to look at, and you're just supposed to find features of it. So it's already there. You should be able to do just what we just did. So x equals negative 2 would be the vertical. This one doesn't cross the x-axis, so it doesn't have any x-intercepts, but it does have a y-intercept. So it's putting together all the different pieces that we've learned so far. And then they have more graphs where you're trying to find the features that are already there. So I have lots of information already posted for you so that you can check your stuff. And then let me know what questions you have, because we're going to work on Delta Math tomorrow, because that way you can check exactly each piece. Like Delta Math is set up so that you can do the Y-intercept. We can do the vertical asymptotes and the horizontal like separately and check all your stuff. Okay, so bring a computer tomorrow so we can do that. We'll answer any questions that you have from Delta Math or this on Wednesday. I'm not having you do just the chapter review. I'll pick some problems and work on it. And then Thursday's test, we'll have all these different things that we have from this chapter. But you've got information you can bring to help you make sure you have that stuff.